let's do some more work. Let's keep going. I mean, we will see some examples of that. For instance, let's consider this one. Here, what we're doing is we're tossing a fair coin, and then after we do that, we're going to roll a die. So a standard 6-7. Oh my goodness! Sorry, I almost knocked something over by mistake. And then we're going to roll a standard 6-sided die. I pressed the button by mistake, so sorry about that. Again, okay, so that's what we're going to do here. Okay, well, it turns out if you look at the events that the coin lands heads up and that we roll a 6, those events are actually independent. Those events turn out to be independent. I mean, let's list the sample space and we'll see this. So here, the coin landing heads up, that's what the H stands for, right? And then, of course, the numbers are, from the die. So that's what we have here, as you can see. Now, let's suppose event A occurs, okay? If event A occurs, then what we're only focusing on are these outcomes, as you can see. Okay, well then, how many outcomes then? Okay, so then if we roll a 6, what we get is only one outcome here. So the probability of rolling a 6 then would be, I think that should be 1/12. I'll have to look at that later. Let's keep going though. So we get then 1/12 as our probability if we roll that, okay? Now, if event A does not occur, then the coin lands tails up instead. So these are our outcomes. Well, in that case, what's the probability? It should be 1. It's 1/6 again. Right? We have 1/6 outcomes because we know tails landed. So these are the possible outcomes. So in other words, the probability of getting a 6 does not depend on whether or not the coin lands heads up or tails up. Again, the probability of rolling a 6 on the die, right? That's the same regardless we get the coin lands heads up or tails up. So the events are independent. I mean, even if you think about it, yeah, that should make sense. It's not like, I mean, in the experiment, we didn't say we're only going to roll the die if the coin lands heads up. So yeah, intuitively, it should make sense. Okay. Yeah, here's another example. This one's a little bit different than what the book does. The book does this with a deck of cards. So I thought it'd be better to do it like this so you have more examples. But let's suppose we have a bag of marbles, okay? There are 10 red marbles, 5 blue, and 8 black marbles, okay? So that's what we're assuming. And the marbles, again, just like the earlier example, the only way you could tell them apart is by what color they have. So if you actually are able to look at them. In the bag, we're choosing a marble at random, but then we put it back. Then we choose a second marble at random. Okay, so we have 2 events here. Let's let A be the first event, right? So A is the first event. Is the event that the first marble is red. So A is the event that the first marble is red. And let B be the event the second marble is red. Are these going to be independent? Well, it turns out the answer is yes. I mean, I did write down what the probability of event A is, but really we don't need that. Namely, since we're putting the marble back, when we draw a second marble, right, the number of marbles in the bag doesn't change. there's still, what is that, 23 marbles there, and there are still 10 red ones, right? So because of that, the events are independent. In other words, when event B occurs, when you draw the second marble, right, you have 10 possible red ones out of 23 possible marbles. And that happens whether A occurs or not, whether the first marble you choose is red or not. So yeah, they are independent. So those events are independent. Okay? Well, what if we don't put it back? That's what this example is. So we choose a marble at random. We hold on to it though, and we don't put it back. Well, then what's going to happen? Well, let's see. So again, A is the event the first marble is red. B is the event the second marble is red. Okay? Well, what's the probability that I guess we don't really, well, that's okay. So let's say the first marble turns out to be red. So I don't think we need this. That's why I'm crossing it out. So let's say event A does occur. So we choose a red marble, right? So in the bag, there's 9 red ones remaining, right? And there are 22 marbles altogether. Again, we chose a marble, it turned out to be red, and we're holding on to it. Well, then what's the probability of event B? It's 9 out of 22. Because now there are 9 red marbles remaining, and there's 22 altogether. Okay, what if the first marble, though, was not red? Well, then there are still 22 marbles there, right? But there are 10 red ones now. Because again, here we're saying the marble we chose was not red. So in that case, the probability would be of event B in that case. If A did not occur, the probability then is 10 out of 22. So notice the probability did change depending on whether A occurred or not. If A did occur, we get this. If A did not occur, we get this. So they are not independent. They are not independent. Okay. All right, let's see. Here's another one. How on earth? Okay. Here's another example. Wait, hold on a second. No, never mind. I need to do that. Sorry, I pressed the wrong thing. I skipped a slide by mistake or something, but never mind. Anyway, we're at the right spot. For some reason, I thought I missed a slide or something because it got a little bit further than this in the other class. Sorry, I just hesitated for a minute. Let's suppose now we're rolling a 6-sided die, okay? We're going to roll it twice. So we're taking a 6-sided die, we're rolling it, and whatever number we get, we're rolling it again. Let's suppose A, right, is the event we get a 5 first, on the first roll. B is the event we get this, we roll a 3 on the second roll. We want to know, are these independent? I mean, I have it on the slide, but if you think about it, you're rolling twice. You're rolling the same die twice, no matter what you get on the first roll, right? Each time, there are 6 possible numbers we can roll from. There are 6 possible numbers that we could roll from. So it's kind of like with the marble bag in the first one where we put the marble back, right? Since we're putting it back, the total number of marbles did not change. Here's the same idea. Since we're rolling the same die twice, there are still 6 possible numbers we can roll. So because of that, A and B are independent. Now the book actually does this, but you could list the sample space. You could write it all out if you wanted to. I mean, there'd be 36 members in there. They write it out as ordered pairs. You could do that. I mean, but if you think about it, you really don't have to. So that's what happens here. So what we get then is that these two events are independent. Again, because you're rolling the same die no matter what number you roll on the first roll. So that's why they're independent. I mean, if you want to see how the sample space, the book does that. So I'll let you look at that if you want. And now, why do we care about events being independent? Well, it turns out we actually have this result. Basically here, if two events are independent, we can easily calculate the probability that they both occur. We can get the probability that they both occur. It turns out to be the probability of A, event A, times the probability of event B. That's what's happening here. You're multiplying. Here, we have the probability of A and B. That's what's happening here. So this is A and B occurring, both occurring. This is the probability of A times the probability of event B. Now that's for independent events. If they're not independent, how would you calculate the probability that they both occur? Well, that takes it's not much more work. That's actually, you have to use what they call conditional probability. That's what you would have to do then. Let me see if I can squeeze one more example in. Suppose now that we toss a coin in the air twice. Let's find the probability the coin lands heads up both times. And this one's actually pretty easy, right? Well, since we you know what? Actually, no, let me not do this one now. I want to get a chance to look at that before class, and I'm doing that. So I'm not going to do that now. Are there any questions about this?